India 2016, and with me I have Mr. Greg Bentley, the Global Chief of Bentley Systems. Welcome, Greg. Welcome to the show. What's your interpretation of the word geosmart?
Well, to me, it means this notion that geospatial technologies are a factor and an essential factor in making our infrastructure smart. And we mean our infrastructure project delivery, which we can improve through greater breadth of information mobility, and then improving the smartness of our infrastructure assets for their greater asset performance through greater depth of information modeling. I think the word geosmart incorporates all of those ambitions. The geospatial technologies are not the final result, they're a factor in producing geosmart infrastructure in a geosmart way.
To make a geosmart world, as you say, we've been seeing location has suddenly become all-pervasive. It's in every aspect that we see, every aspect of infrastructure, building, our lives. How has it happened?
Well, the 3D environment in which we live and in which our assets are operated has converged now to be the 3D environment in which infrastructure engineers conceive and conceptioneer in the context of capturing that geospatial environment, as we can now do with new technologies that we're showing here. And then the operations of our infrastructure assets are roadways and railways and metros and power generation and transmission and distribution, our water systems. They're all experienced in the geospatial context. So being able to relate the reality of how infrastructure improves our lives to the virtuality of how we as infrastructure engineers can improve the projects and the asset performance, that convergence has just come about to a degree that I think it really is the major factor in going from geospatial to geosmart. The immersive world we live in is also the immersive world we engineer with our technologies from Bentley Systems and putting that all together.
How would you say the user behavior changed over the years?
Well, users of geospatial technologies once were professionals and needed to know about special hardware and special survey techniques and so forth. By now, the users of geospatial technologies are those who are creating and maintaining and even utilizing infrastructure assets. Think of our smartphones now being geosmart and helping us to navigate on roadways and railways and metros, where even the infrastructure itself becomes a smart component. Navigating the roadways themselves are intelligent, the metros can communicate with the riders and so forth. So the users of geospatial technologies, more and more so, aren't those who are specialists, but those who are constituents and citizens. And likewise, the maintainers of infrastructure now have the digital engineering models, the digital DNA by which the assets were constructed and realized on their mobile devices to help them immersively make decisions about maintenance and operations, fully informed by the choices the engineers made when they engineered them to start with. This is new, this continuity, this reach and convergence from the specialists who were planning are now planning and realizing and engineering and then operating. To have the digital engineering models span that extent is to say that our users are now new categories of users who are making decisions and gaining benefit from the infrastructure decisions the engineers made with geospatial inputs.
what are the new disruptive business models in this whole chain that you were explaining?
Well, for those of us in the software business, there has been disruption. At one time, the software business model was to sell perpetual licenses of our software, and then the risk of fit for purpose and obsolescence became that of those who owned our licenses. We have aggressively embraced in our industry, but especially in our company, a preference for a business model involving subscriptions so that our users continue to get benefits and we share in the results-oriented outcome for the software to continue to provide value over the lifetime of infrastructure projects and assets. So that's a disruptive business model in software, but one which is a benefit to our industry ultimately, to have more concern for and be working toward the future and the future benefits.
Can you share more further details on this interesting concept from Bentley, reality modeling?
Well, reality modeling is our term for when observations are made of the as-operated world. They can now be captured from simple digital photography that is everywhere, and then processed into, and this is the particular innovation, the form, we call it a reality mesh, of 3D model that the engineers use to, in our software products and others, to do their optioneering and their project delivery work. So in this case, and especially, and now, unmanned aerial vehicles, drones, which are best at producing photography and video of our infrastructure assets. That's everyone's best idea for how to use drones advantageously in meeting our infrastructure challenges. Those photographs are not just images for people to look at. Our software turns them into 3D mesh models in the frame of reference to provide the context for the engineering work, either in a new project or a retrofit, and then the same survey can then be done continuously over the well, first of all during construction and then during the operations of those assets. So instead of surveying being something that's done only very occasionally and intermittently, that would be so if it required special equipment, special crews, even laser scanning requiring both of those. And laser scanning, while beneficial, produces a point cloud that's computationally not tractable. It's large and dumb. But when you instead can have the ordinary devices that anyone can use, and this increasingly is drones and the operations and maintenance fleets of infrastructure assets for maintainers and operators, and even our own smartphones to add observations from the ground, with the software able to process that into a geometric representation, a mesh with photorealistic accuracy, but in the same environment that in which the engineers are doing their work. This convergence to make the work of infrastructure professionals more geo-smart thanks to this context, and lasting longer into operations and maintenance because the reality mesh model continually surveyed and updated and compared during construction, so you can see the progress and the statusing, and during operations and maintenance to look for changes and inspection and continued structural integrity and so forth. We think it really reinforces this notion where the geospatial technologies are not separate, but part of a geo-smart convergence in the work of engineers for project delivery and asset performance. So it just happens that the new software technology, which makes the existing hardware advancements in photography in our smartphones and in our drones able to create and bring the geo context to the work of all engineers, and the work of all engineers into the geo context together through project delivery and asset performance. I think it's a real breakthrough. It's the reason I say that we're at a reality modeling convergence of the geospatial technologies into infrastructure engineering.
Let me understand in a layman's concept. A photography is what you would, till today we would call non-geo. I mean, till you don't have the geo context to it, but so what you are essentially doing is taking the non-geo thing and connecting it to the geo-connected world. And
what a great insight. So the fact is that the photos we take with our smartphones are geo-tagged, and our smartphones, of course, are always aware of our geospatial location. We don't make a choice about that, but it gives us many advantages as in the way we utilize our devices, our information mobility. We say mobile devices. It's the mobility of the information that is enhanced by the location capabilities of our phones. But when we take any photograph, and of course we could purposefully take photographs when we want to create geo-smart representations of our infrastructure, were it to be this conference center or where we would propose a metro to run here from Delhi to Noida, for instance, we would use simple digital photography. We might fly a drone, for instance, in the new Nagpur metro. A crew learned, and it wasn't a specialized crew, in a week what it took to use an ordinary drone, for which it was easy to get permission, to fly the proposed route of the metro, taking overlapping oblique photographs from the air. But those are naturally what drones do. They take overlapping oblique photographs. The software can process those through something called aerotriangulation and yield a 3D model in the mesh format, the geometric format, in which the models of the new metro would be designed by the engineers. So it happens that whenever we take a photo, the photo captures information which, when compared to adjacent photos, can yield, as our eyes do, when we can think of surveying as being continuous, because it doesn't require specialists, it doesn't require special hardware. The software is the breakthrough to enable this continuous surveying to be part of our workflows at every stage of engineering and every stage of operations and maintenance of infrastructure. Then GeoSmart doesn't become something we strive for and imagine. It can be part of every workflow now.
so would you call it a technological innovation from Bentley? Is anybody else doing it, or it was?
Well, others are producing models from photographs. What we can particularly do, and we feel it is our particular contribution, is to integrate the workflow so that the 3D result from photography is in exactly the same form factor as the engineer's own work. So of course we lead the world in infrastructure engineering software, where the civil engineers and the structural engineers, the building systems engineers, the plant engineers of the world use our software to do their designs and retrofits and so forth, and their construction in 3D. Having that now include the context captured from photography and continuous surveying, something we can do particularly well, and we do happen to have software that focuses on that practical aspect of it. The result of the digital photography is better engineering and pervasive engineering throughout the life cycle of the infrastructure asset.
We heard about Bentley's involvement in Pope Francis's the planning and execution of his visit in the US. Could you share some details about it?
Pope came to Philadelphia, which is our headquarters city, if you like, last September. In the summertime, we realized that we could conceivably apply this reality modeling technology to create a 3D city model of Philadelphia, which wouldn't be just to visualize and show and plan, although that could be useful for the Pope's visit, but actually to provide the basis for the engineering of the temporary structures, the barricades, special facilities, the stage, and so forth for the Pope's visit. But for that to work, it had to be done in just a few weeks. So that was a challenge and an experiment for us. So we volunteered pro bono and asked which of our colleagues would be willing to work on their own time to come to Philadelphia and help make this work. Because the technology hadn't been applied just in time for a event which had a deadline of this sort, and we were able to substantially contribute to the success of the Pope's visit. And we like to show the result of the 3D city model created with a few helicopter trips in the air and some existing aerial photography that produced the basic model prior to that, all processed by the software and then provided in our microstation and our application environment for the engineers to actually do the work required to provide the facilities for the Pope's visit. We weren't sure all that would work well enough first time applied in this respect, and the outcome was very positive. We learned a lot, and our users now will benefit from that experience in how simple and quick it can be to take advantage of reality modeling for, you could say, asset operations of the whole city of Philadelphia and its most important event ever, welcoming the Pope. And the visit came off successfully.
Which are the agencies, the federal agencies or the municipal agencies that you collaborated with?
Well, in the United States, that involved our Secret Service, is our part of our national services that has responsibility for events with foreign dignitaries, and of course the police and the organizers in the city of Philadelphia were users of the reality model as well.
Thank you. Thank you. Thank you so much.